in China, including those introduced and the invasive species. So for the taxonomy, from 2002, we published the first new species of the keyword, the Asteraceous invasive, and yet now we have published several species of the Asteraceous, and also in past 5 years, we have published some new species of even the Nobenia, and was the reappraisal of the Lymphoides coronata. It is more than 100 years have not collected the sample from the field. And it's very important in the recent years, based on the morphological differences of the Otenia, we published 2 new species. One is Guanyuensis, another one is Fengxianensis. Both are from the southwest China. And it's very important now we use the molecular data to support the morphological differences. So now next, I think also the trend for the nowadays taxonomy of plants. So with the collaboration with our partners in Madagascar, we published a new species of the Hydrostachys, that is reprine, that is in river and also in the creeks. So it's a unique species, and also for this genus, it's very interesting. So maybe in the future we have some more new findings. So for the population genetics during the past 10 years, we revealed that 2 cryptic species of the Cordilleras, that is the north and the south, based on either the chloroplast and the nuclear genes. We could see here the north type, south, and the north type. Maybe these are 2 new cryptic species. And also we conducted research on 4 Sagittaria species that are endemic to East Asia, so including the Potamotifolia and the Pigma and the Litrensis. It's very interesting that the endemics, it's a regulation of them. It's from the Hendain, even Hendain Mountains or Central China and the East China, and also the range expansion is in response to the quaternary climate oscillations. I think it is interesting for some more aquatic plants that endemic feature to be studied. So the Potamotifolia is another example to tell us a story night for the biogeographic isolation. I think that's important for the aquatic ones. That's an aquatic habitat is very important for most of us. Where I understand tonight the universal of night habitat maybe leads to a lower differentiation, but actually some of the aquatic plants that's totally different. For this one, even the for Niatus and the Bacteria, this is different because of the geographic isolations that lead to some genetic differentiation. Another one is just about the Otenia. So Otenia accumulata have 5 varieties in China, and because of they're adapted to some specific small rivers or creeks, so no isolation and leads to limited inflow. So for the genetic differentiation in the variety, maybe it's lower, but among all these different varieties, it's pretty higher because of the limited inflow. Even in some of the specific varieties, example for this this variety, so in some small habitats or totally different habitat, maybe some differentiation occurred. It's really there. For example, we have there, we could have some cryptic varieties, maybe for example, the Baiso and Lutai populations. That's some differentiation occurred. So for the breeding systems of the plants, Nymphoides partata. So it's a dice valley with a dash valley. So for this hydrostylus syndrome, it's very important to review what's the happening of the ratio of the different stylus. So our field investigation revealed that about 30% in the single flora move. That's very important because for some of the populations, they could generate from their reproductive uh, production. So for the flowering rush, it's another story. So their anther opening, reversible opening. So when some rain or some bad weather, the anther could close, then waiting for the drier and also for easy to disperse their pollens. That's just another example of plants. And also conducted population system evolutionary analysis. So it's interesting that for it's the same as the origin of the aquatic plant, the hydrophyly with at least 8 separate regions. It's just depending on the habitat. For example, for those even seagrasses or some of the other, for example, the Alisma sagittaria and this Alismaceae family. So for the 18 aquatic genera have appeared 2 hydrophyly, and the other 7 genera, it's different, either the Mayflower or Aphorophyly or Hydropotogamy. So for the phylogeny and the biogeography of some families, we conducted analysis on Hydropotaceae, including all the genera and about 120 species. So based on the ancestral areas of reconstruction and also the differentiation and origination of the different genera. So we could have 2 clades to be separated. For example, the clade 1, so most of the marine lineages of these families are in this clade 1. So the marine lineages originated in Asia, so based on our investigation, and also the Vallisneria originated in either Asia or Australia. And for the clade B, it's interesting that it occurred in Africa or the South Hemisphere during the Eocene, and diversified in South Hemisphere during the Tertiary. For the Myrophyllum, it's the only genus of that family, so we our study revealed that this genus originated during the Oligocene. That is about 22 to 34 million years ago. So for earliest diversification of the extant Cordilleras is in Australia during the Eocene. So it's interesting. So I think in the future for the aquatic plants, we should pay more attention either to Australia or another story. So we may see this Potamogeton, that family. So for this Potamogeton, we could see this one. The Madagascar and the continent of Africa, it is very important. So the recent most common ancestor of this family might get to the mid-Eocene and have lived in the Madagascar and Africa. And during the Miocene, at least 3 times of exposure from either Madagascar or Africa to Asia and Australia. So this is one species from Kenya with branched inflorescence, and this one is in China and Asia, only single inflorescence. So in recent years, we are focusing on adaptation of genetic adaptation of the aquatic plants to different habitats. For example, we all know that life was originated from water, so I believe this maybe. And for the multiple regions of the plant, it's very important to see here. Some of the even genus, general or families, They are monophyletic, but most of them, they are from the terrestrial back to the water. So this is some of the example of the aquatic origination for either the lemur, the Aquarius, and Alice Martinis. And from this tree, you can see for some of the groups, for example, the Aquarialis and also the Alice Martellis. This is a pizza, and to the monocots, and for the Cordilleras, including those Lumba lucifera and also a lot of species like North American Lutea. So they are here, here. So the Alice Martellis, it's interesting. This group includes all the marine angiosperms, that is the seagrasses, and also with a lot of different types of living forms, including the emerging, floating leafed, or even submerged forms. So it's a ideal group studying the adaptation to aquatic environments. So still, we have some complex relationship among even Alice Martellis, for example, the Aricia and Ophidiaceae. So these three, I think, suggestions for them, but we don't know. So we generated about 59 transcriptome forms of 89 species, and including 91 samples, including all representing all the genera of that Alice Martellis. So let's the T is on the maximum likelihood. So based on about more than 1/3 nuclear orthodox. So you can see still some states with a very low support, but with the internal certainty assay and also the previous scored analysis, we found that the phenolite analysis also could reveal some hybridization event and some other, I think we see the voices to the conflict. And we believe that so based on the research, the most reliable relationship among the three groups, the core Alice Martellis, and also the Aricia and Ophidiaceae. So the core Alice Martellis, it's a sister to the Ophidiaceae and also Aricia. So that's our idea about this one. And also, the conflict maybe is a result from the introgression and also areas some other reasons. And for the WGD, the whole genome duplication is very important. So we found that based on the analysis, so about 18 cumulative WGD events across Alice Martellis. So interesting that one of them occurred as the most recent common ancestor of this Alice Martellis. And also 3 others occurred as a seagrass lineage. So for all these blue and this is seagrasses. And also for some of the seagrasses, it's very important either for the gene analysis, the genes, the several light or ethnic or related genes or lost in the seagrasses, only in the Australasia, but present in other seagrasses. It's interesting, and also even in the freshwater species. And for the stomata related genes lost in the both submerged freshwater species and seagrasses, that's easy to understand. But interesting is that nucleoalamine synthesis genes, so which are very important to the iron intake, so expanded in both submerged freshwater species and seagrasses. So that's interesting, and also maybe future we have some more study. So another story is current. Now current is our research revealed that for this Aquarius Eta renoi, it's only experienced a single independent WTD, and also with some subphylum dominance. I will tell you a story about this one. So for this Aquarius, it's the earliest species from the monocots, you could see here. So either the genome structure of this species is conserved, but we need to know why. So for the also the constructing of the karyotype of this Aquarius, we after analysis we think it is from the base number 6 to 12 chromosome. So then the basic chromosome number. So that is the way of the Aquarius. And also it's very important that that's in Aquarius, so the more chromosome arrangement events, such as chromosome breakage and fusion, is occurred than all the other monocots. On the impactors that constrain the evolution rate of the monocot genome collinear structure, we use the lotuses outgroup. So the key factors we think is methylation of the upstream and downstream regions of genes. That's one. Issue specifically of the gene expression and the number of exons, and also the type of region of the duplicate gene, either the WTD or single copy or tandem duplication, some of these. So it's about an association between the expansion and the construction of the gene families in Aquarius and also in monocots. Example, the dot 3 is lost in monocots and also in lympha and water lily, maybe, and it's because of the primary roots and also some other morphological characters are degenerated. And from the LPR1 and the LPR2 expansion, it's very important could help the monocot adapt to the lower inorganic phosphorus aquatic environment, and also the primary root or the taproot degeneration. So another story is about the genes duplicate genes, the evolutionary pattern of them. It's just a case study as we conduct in the notice. So the vast majority, we know that of the plantains are duplicates, but for this duplicates also provide the genetic material for the species. Species evolution is very important, some new species. And why we choose the lotus? Because the lotus and it's one of the few flowering plants that only experienced one WGD or the whole genome duplications. So it's very important. For example, in the Arabidopsis or rice, they have 2 or 3 or more whole genome duplications, but in the lotus, maybe only 1. So the lotus is a base group of the dicots as here as Cordilleras, and also the we choose it as a material because it has only undergo one diploidy, and also another reason is like the genome structure is relatively conserved of the lotus. So based on improved genome assembling of the lotus China, and so we conduct some analysis either of the phylogenetic position of the lotus WGD duplication gene classification and the functional arrangement of all the WGD genes. The interesting that for all the WGD duplicates are mainly enriched in the single transduction and transcriptional regulation. It's very important. So the significant differences in expression patterns and structure functions of the various types of the replicated genes after single WGD notice. So we think that the reason for them differences are from the evolutionary rates, tissue expression bias, in the exon number, and the protein-to-protein interactions. That's all these reasons. And for some of the distribution of the transposes and the methylation levels among different types of the duplicated genes after the WGD, that is very important. The promoter region has the least distribution of transposes and the lowest degree of methylation. That is interesting. And also from the single copy genes and Asian dispersal duplicate genes, it's has a very important housekeeping functions. That's I think we think that it's very important to conserve the stable genome and also for the gene function. So for the gradient differences in the expression level, evolution, and the methylation of the replicators, and we found like the different degrees of the expression differentiation is very important. We have some of these either for group A here. We could show say a lot of genes for the different expression levels and also the methylation level. So the notice also show genome dominance after the 1-WGD. The one set of the genome, for example, the RF of Asian polyploid lotus, most of the genes than the other set of the subgenomes. That's very important. Another one is the expression level of the RF is higher than the MF. Methylation level is the other story. MF is higher than the RF. So that's some of the research in the past 20 years, and now we published our paper on the Alice Martelli's addition to the aquatic environment. So as reviewed and some remarks from the Richard. So compared with the terrestrial grasses and even seaweed, the body of the research within seagrass, the seagrass is magnitude small. So maybe in the future we need pay some more attention to the seagrass, how the aquatic plant adapt to the seawater and also to fresh water. So that's some of our research. Thank you for your patience, and I would like to thank also some of my colleagues and the WGD Aquatic Plant Research Group, and a lot of my students, and also my colleagues, and also with the fundings from the National Natural Science Foundation of China and the Chinese Academy of Sciences. Wuhan Botanical Garden providing the facility to conduct our research. Thank you. Thank you very much.
Qingfeng, thank you very much. There are 2 questions in the chat room. Could you see it? In the chat room, there are 2 questions.
Okay.
So one of the questions says, Dr. Wang, excellent presentation. Can you tell us about the invasive species of Australia? Do they have the same characterization or constitute species from other biological corridors?
Can you see it?
Pardon? Check it. I couldn't find it. Question?
I just
Please.
sent the question.
Yes. Yes.
Okay.
The first question is, what can you tell us about the invasive species of Australia? The first question. Can you see that in the chat room?
Okay. Chat room.
问答. There are 6 questions.
Us about the invasive species of Australia. Will they have the same characteristics of African species from other biological corridors? Oh, okay, I got it. So for I'm not quite familiar with those situations in Australia, but we do have some maybe in our field survey. Most of the invasive are introduced from the America, South America, including those odd hyacinths and also the Pistia and Ortonantera and some other species. And even now some terrestrial species are from South America and some are from Africa, but a few. Maybe one species is from Australia. And for the situation in Australia, I'm not sure whether the water hyacinths and some other species are introduced to Australia. And I think maybe it's a little bit different because of the climate and also the native vegetation is a little bit different. So I'm interested in some of the native species in Australia, for example, even the Alismatecia, some endemic species, even general are there. So maybe later we have some more communication either on this topic in Australia. Yes, for the submerged plants, so no need for them to conserve the stomata. So I think that's an important adaptation from the terrestrial to the submerged water environment. So next is even genetically maybe some degeneration of the genes control the formation and the development of the stomata. So that's my answer.
And there is one question proposed by Dr. Liu. She said, do all the submerged plants lost their stomata?
Yes. For the submerged plants, it's no need to preserve like stomata because for the what we see in even the carbon oxygen, the exchange, no need. It's just another way because they absorb the carbon versus not as a free carbon dioxide. It's another one. So we could have some examples from even the Azores and also the submerged the Nayas and the Hydrina, some other species. So no stomata.
Okay, there is a new question about the dispersal between Africa and Madagascar. The last question.
Yes. Where is it?
The last question in the answer room, question room.
Dr. Juan, I sent you through the chat the question about Madagascar and Africa.
Oh, yes. African species to have a gene in the medicine with more than one disposal is
The species to have
of Madagascar, and we can attribute. Oh, it's a good question. So we have some other examples, or now it's we are working on that one. So since the separation of the Madagascar from the mainland Africa, the continent Africa, so now we have some other examples that maybe for some of the ancestor, the common ancestor, maybe it's disappeared, but very good stories about the Adansonia. So in Madagascar, we have 6 species, and the continent Africa is one species, Tata, and Australia another one. So which one could be in the ancestral? I think ancestral origin. So we're working on this. So for the origin, the mainland Africa, the continent Africa, Madagascar, Australia, we should have a new idea on this one. For the even the floristic or the fauna. So we are trying to find some more data or evidence to support our idea, but maybe after several years, I could say several years, maybe we could have some new findings.
Thank you, Dr. Wang. We have another question about the Cornea crassipes, about the purifying features in rivers, if it can be used to clean polluted water. I also sent it in the chat.
Thank you. For the water hyacinths introduced in China, we firstly introduced as ornamental, also as some food for some animals. But now it's a big problem. Yes, it's to purifying the water, and some way it's okay, it's working. But another problem is about the transportation of the water. In China, in Yangtze River, south of the Yangtze River is a big problem, and so it's I think it's a bias. Is some maybe we could benefit from it, but the problem maybe is even the environment problem is even serious. So that's my suggestion. So we are trying to control, but how to control the expansion of that species? That's a little bit hard to demonstrate, I think. And even now in Africa, Lake Victoria, in Kenya, Lake Naivasha, and some other lakes, is also a big problem for the hyacinths, like Cornea crassipes.
Okay, is there any more question? I think it's time for Qingfeng's talk. Thank you very much, Qingfeng.
Thank you very much.
Well, thank you very much for your presentation. So now it's time for the next presentation, please. So I'm going to share the screen to give you information, to present the next speaker, who is, okay, I will share the screen and then I will talk a little more about Javier. Are you able to see the screen, please?
Yes, Alina.
Yeah. Okay, so the next speaker is Mr. of Science, Master of Science, Javier Cornejo, who is a researcher and professor at the Universidad de Guayaquil in Quito. And he's in charge of the Guay Herbarium at the Department of Botany, the Faculty of Natural Sciences at the Universidad of Guayaquil. His work is mainly on the floristic composition of South American Pacific mangrove swamps. So he's been working in Colombia, Ecuador, Peru, and other areas. And also his research is on the terra firma forest from Western Ecuador. He's been working also in the taxonomy and floristic discovery of many families, in particular, Neotropical Paraceae, the genus Pentagonia in Rubiaceae, genus Meliosma Fabiaceae, Forestiera in Oleaceae, and in families Lecipidaceae and Cleomaceae from Ecuador. Javier is a very prolific researcher who is exploring a lot in the coastal part of Ecuador. And his talk would be about the botanical studies in coastal Ecuador. Right now, he had submitted the recording, so we will share his recording. He is in the room now, so he will be happy to answer any questions. And so I'm going to share right now his talk. I want to make sure that if you please could let me know if you can hear the talk.
Good morning from Ecuador. This is Javier Cornejo. Let's talk about botanical studies in coastal Ecuador. Ecuador is a small country located right in the tropical belt in northwestern South America, south from Colombia, north and northwest from Peru, and bordered on the western side by the Pacific Ocean.
I'm sorry, just want to make sure, can you hear his presentation?
Yes, yes.
Wonderful. Then I will make it, sorry.
18th century, among the most credited naturalists who visit the coast of Ecuador is Alexander von Humboldt, a German geographer, naturalist, and explorer, jointly with Aimé Bonpland, a French collector of plants. Both were working mostly on Andes of present Ecuador and Peru. Once in Peru, they went down to the port of Lima, took a ship, arriving Guayaquil on January 1803, and spending 6 weeks gathering the information from the southwestern part of the present Ecuador with the help of Juan Tafalla. All the collections gathered by Bonpland and Humboldt from America were sent to Paris Herbarium to be carefully studied by Carl Sigismund Kunz, one of the best taxonomists at that time. The results were published in Nova Genera et Species Plantarum, comprising approximately 4,500 species of plants. Many of the new species of plants that are common from coastal Ecuador were officially published for the first time. On 2020, a book that deals with the visit of Humboldt and Bonpland in detail to the area of Guayaquil has been published. From 1798 to 1804, Juan José Tafalla settled in Guayaquil. He collected around the city and towards Taura, Rio Bulubulu, Cordillera Chongoncolonche, Yaguachi, Jipijapa, and other places. The idea of Tafalla was to produce the first flora of the region. He collected over 500 species, describing in detail in Latin in situ, and also with his team painted over 300 plates of vascular plants. All of that material with detailed letters were sent to the Oficina Botanica to Hipólito Ruiz and José Pavón, who never published that material. Unfortunately for Tafalla, his collections and all his work remained lost in Madrid Herbarium for almost 200 years. It was until 1989 when Dr. Eduardo Estrella discovered all this lost material and made an exceptional editorial work publishing the Flora Guayaquilensis de Juan Tafalla. Juan Tafalla received the visit of Humboldt and Bonpland in January of 1803. Tafalla took Humboldt to collect to his favorite places, and Humboldt and Bonpland, as it is known, they published their work before Tafalla. That means that many of the new species that were discovered by Juan Tafalla were not credited to him. We know that after the publication of Flora Guayaquilensis, thanks to Dr. Eduardo Estrella for this masterpiece. And in the 19th century, the coast of Ecuador was visited by Henrik Franz Alexander Baron von Eggers. He was a Danish soldier and botanist. From 1891 to 1897, he made 1,700 collections of vascular plants, particularly from the coastal plain in El Recreo, his own hacienda, and Balao in the province of Guayas. El Recreo is a locality placed near Bahia de Caracas in the province of Manabí. In recent years have been observed that many of the species collected by Eggers in El Recreo that at that time were published as new species, and most of those are endemic to coastal Ecuador, are still present there. That means that the forests of El Recreo and surrounding areas as Cordillera del Bálsamo could be regarded as a living type genetic bank. During the 20th century, the taxonomic studies of plants of Ecuador increased with the research and contribution by several prominent Swedish botanists. Flora of Ecuador is the pivotal publication about the plant taxonomy of Ecuador. Right after ending the Second World War, Gunnar Harlin, a botanist from GV&S Herbaria, came to Ecuador, starting his collections for this project from the Clementina farm that is located in Los Rios province. La Clementina is the largest banana farm of America and perhaps the whole world that keeps the forest of Samama Hills because collects the water they need for the crops downstream. In subsequent years, Gunnar Harlin and Baron Ben Espard visited Ecuador, gathering thousands of collections of plants of the country. Many of those from the coastal area producing hundreds of new species. To the present, Flora of Ecuador is the best taxonomical treatment about the plants of the families of the country, the only one actually. However, the coast of Ecuador is still under-collected in most of its ecosystems. During the 20th century, the flora of coastal Ecuador was intensively studied at some localities by North American botanists Callaway Dodson and Alvin Gentry. Callaway Dodson was a taxonomist on orchids for over 50 years. Alvin Gentry studied Neotropical Bignoniaceae. Both combined efforts to produce the flora of Rio Palenque that was the first flora of the country in 1978. Flora of Jauneche, that is the biological extension of the University of Guayaquil in 1985, and Flora of Capeira, a dry forest that sadly remains not published until present. Dodson and Gentry were studying the plant composition and habits in each of those localities in correlation to the levels of pluviosity, demonstrating that plant diversity and strategies increases with the amount of rains. It is most likely that they noticed that the life zones and ecosystems in several places were closely arranged with each other, being the coast of Ecuador an ideal place for botanical and floristic research. At the same time, they were doing field work, and in the 70s and starting the 80s, they were alarmed about the destruction of forests. Massive areas of native vegetation were converted to cattle farming. They published that in Biological Extinction in Western Ecuador in the Annals of the Missouri Botanical Garden in 1991. That is the first publication in English language that called attention worldwide what was sadly happening on the coast of Ecuador. Despite the alarm given by Dodson and Gentry in biological extinction in western Ecuador, to the present, the efforts for conservation are still insufficient. In recent times, surprising rediscoveries of local and regional flora have been done. That is the case of Gastroenter Sextantus, the species on the left side of your screen with beautiful bright orange cleistogamic corollas. That is a low herb of wet forest rediscovered from Centinela the last year. By initiative of colleagues from the Field Museum, in companion with a team of almost 10 people from several institutions in which I was honored to be part of that expedition, the species was found in several populations in the same area previously reported by Johnson and Gentry. Another case even more surprising is that of NASA Humboldtiana, originally gathered by Richard Spruce in 1861 in Tungurahua, and only known by the type, until a recent rediscovery on the western side of province of Chimborazo. These two examples perhaps means that we still have time for saving species of plant, endangered species of plant in western Ecuador. At present, most of dry forests in continental Ecuador are in secondary condition. One of the best conserved dry forests can be found in Puna Island. The main reasons that can explain its conservation are the isolation and the almost total absence of roads. The flora of Puna Island have been carefully studied by Jens Madsen and collaborators, based on a splendid collections of plants gathered by the first author. Flora Puna not only deals about vascular plants, but also provides historical information about plant uses since the colonial period. We have to keep in mind that when Spanish conqueror Francisco Pizarro arrived first time to the Gulf of Guayaquil, he was very impressed as a witness of the Puna pre-Hispanic Navy. Those guys were using balsa raft built from local trees and lianas. They were going to the war against Tumbas. Another aspect that must be highlighted is that what had been found on the phytochemical compounds of plants from coastal Ecuador. In recent years, with the collaboration of Dra. María Eugenia Rondón from Universidad de los Andes, around 50 species of plants have been screened. Most of those abundant alkaloids correlated to the type of soils have been found. It is most likely that the species from the dry forest could be like a mine of alkaloids and another compound like oils that are very attractive for medicine, industry, and other purposes. There are two main extra-Andean cordilleras on the coast of Ecuador. Chongoncolonche, that is located from southern Manabí along Santa Elena province and reaching Guayas province, and Machu Chindul Mountains, located at the northwestern part of the country in the provinces of Esmeraldas, reaching to northern Manabí. A pioneer work of the flora of Chongoncolonche was the publication by Flor de María Valverde, at that time professor of Faculty of Natural Sciences at the University of Guayaquil, in 1991. The title of that work is Present Condition of Natural Vegetation of Cordillera Chongoncolonche. That publication was achieved thanks to the partial collaboration of Callaway Dodson and Alvin Gentry, and deals mostly with the dry forest flora up to 350 meters above sea level. On August 3rd, 1993, was an airplane crash on the top of Chongoncolonche Mountains in which Alvin Gentry passed away. One of the survivors, the director of White Herbarium, Carmen Boniface, decided to start the study of the flora of the mostly floristically unknown upper part of Chongoncolonche Mountains, that is from 400 meters above sea level up to 1,000 meters. Subsequent publications about the flora of Chongon-Colonche takes mostly identifications provided in these two mentioned works. In 2006 was published the floristic checklist of Machu Chindul Mountains of northwestern Ecuador, thanks to the efforts of John Clark, an excellent and prolific collector of plants, with David Neal and Mercedes Asanza from the QCNE Herbarium. That is the first publication of the Cordillera, of the flora of the Cordillera in northwestern Ecuador. A good example to demonstrate the floristic affinities between Old and New World could be the genus Meliosma in the family Zabiaceae. Meliosma exhibit an amphipacific pattern of distribution. Abundant fossil records of endocarps and leaves of Meliosma have been found in Europe, Asia, and northwestern North America, suggesting that ancestral species crossed from northern Asia to North America through the Bering Land Bridge. An old record of Meliosma have been found from the Upper Eocene in South China, named recently as Meliosma eozenica. At that time, during the Eocene, southern Central America and coastal Ecuador was under the Pacific Ocean. Once the Andes uplift, Meliosma colonized and produced massive process of speciation. The absence of fossil records of Meliosma from the Neotropics confirms a recent presence for that genus. The genus comprises around 80 species in the Neotropics, mostly of Andean distribution. The few endemics on coastal Ecuador, as Meliosma gracilis on the left side, most likely is a derived species from Andean ancestral origin. Another good example to demonstrate the affinities of neotropical and old world floras is the family Lecitidaceae. The Lecitidaceae, known also as the Brazil nut family, is composed of 10 genera and 232 species in the Neotropics. From those 232 species, 46 occur in Ecuador. During recent years, 10 new species have been described in this family jointly with Scott Morai. At least 9 of those are restricted to northwestern Ecuador. The flowers and fruits of Lecitidaceae are predated by agoutis and pacas. Actually, the flower is predated once it's fallen on the ground, but these vertebrates feed on the areoles of the seeds and helps in the dispersal of the species. There are several genera with symmetric flowers as Gustavia. You can see Gustavia at the upper left corner, and also Grias. And there are other group of genera with zygomorphic flowers as Schweilera, Lecitis, Corupita, etc. In Schweilera, for example, you can see Schweilera integrifolia at the upper row with a longitudinal section of the androphore in which you can see the coils or chambers. That adaptation is for bee pollination. Yeah? And those androphores are very important for taxonomic studies. This feature was discovered by Scott Morai during the past 15 years, I think. As the taxonomy was often confusing and hard to tell from herbarium material, was needed to go to the field almost to check each tree of each collection. In herbarium, you can see lots of collections of Lecitidaceae, but what happened is that the androphore get smashed during the herborization process. So it is needed to go again to the same place, the same locality, even to find the same tree and collect the flowers. To do the sections in the field preserve the flowers in alcohol for further studies and takes photos in situ in order so we can study the coils. And for example, in this Schwalera integrifolia was very important to discover that it has a triple coil. Schwalera integrifolia was firstly collected by Juan Tafala nearby the Bulu Bulu River that is at present the Reserva Ecológica Manglares Churute, where the high population of Schwalera integrifolia was found still extant there. That was a very good field discovery because helped a lot to Scott to establish the generic characters to recognize that clade. A similar example is also the Caparaceae family, the caper family. Caparaceae broadly distributed also in the New World as well as in the Old World. In the molecular tree on the right side, you can see the Neotropical taxa in light blue and blue color mostly for North American taxa. Yeah, but you see that all of those American or New World taxa are correlated and genetically derived from the Old World taxa. For example, the green ones are those from Africa, and the orange ones from Asia. So the oldest relatives of Neotropical Caparaceae are those from the Old World. That is a fact. An interesting taxonomic discovery that deserves to be mentioned is that of Mangleticornia ecuadorensis. Mangleticornia ecuadorensis, a new genus and a new species, restricted to mangroves and adjacent salt marshes in the Gulf of Guayaquil, and even present in the city of Guayaquil, well, as an infrequent floristic element. The leaves are not as the usual plant. Mangleticornia has no those kind of leaves with developed blades, and the corollas, the flowers are so tiny and with no corollas and with no visible calyxes. The stigma is only 1 millimeter long when present, and the anthers up to 1 millimeter long, and flowers are not often observed. The species has been very few times collected and is mostly an overlooked species in mangroves. Here we have a selection of new species of trees with enormous leaves, all of those found on the Chocoan area during the past 20 years, from coastal plain to the western side of Andes, mostly of families Lecetidaceae, Rubiaceae, mainly genus Pentagonia, and also even in the Lauraceae. And that Aniba ecuadorica was recently published the last month. It is interesting to see that in the Chocoan area, as the pluviosity is higher, the species of plants tend to produce larger leaves and also larger fruits. It is still unknown if the larger fruits that are present on western Ecuador is the result of co-adaptation with extinct megafauna. That would be a very interesting case of study. Here we have a good selection of new species described during the past 20 years also, but these are restricted to the equatorial Pacific dry forest. Several of those are species of seasonal behavior. It is interesting to note that, and most of those were not previously collected or found because you cannot find it during the dry season. They are only visible during the rainy season. Most of those reproduced by bulbs that are under the ground, The vegetative part dies, decays and die, and actually disappear during the dry season. You cannot observe the species. People could easily think that there's no any species of interest in some area, for example, as is the case of several of those recently discovered. But when the rainy season is coming, the early rains helps to sprout for those bulbs, and the species are there. You can see them. And that way we have found several new species. For example, in the genus Sanctosoma, as Sanctosoma guayaquilense, Sanctosoma gracie, and several other, for example, in Amaryllidaceae family also with the same behavior. Yeah, we even have found orchids. You could say orchids in a dry forest. Okay, there are some parts of dry forest that are under the horizontal precipitation, mainly from in the Manabí, in the area of Manabí province. And there you can find endemics as Anthurium gallardum and also Epidendrum aromoense, both found in the same locality in the Aromo. Yeah. Other species of interest are Dioscorea magnibracteata that produce tubers that storage starches that could be edible. And Psidium guayaquilense that has been recently screened to know the chemical composition and has very interesting composition or concentration of oils. Yeah. The oceanic currents not only affect the terra firma ecosystems, but also produce a strong influence on the floristic compositions in mangroves. Therefore, two floristic subunits have been found after carefully studying the pattern of distribution of the species throughout the mangroves on the coast of Ecuador. Two floristic subunits known as the Chocoan mangroves and the Equatorial Pacific mangroves, each of those correspond under the influence to each oceanic current. And in the Pleistocene existed well-developed mangrove and terra firma ecosystems on coastal Ecuador, with closed canopy that allowed umbratic understory in cooler environments in comparison to today. Las Vegas people is the earliest human group that appeared at that time at the peninsula de Santa Elena. Fossil fruits of Bonellius brucei, a primulaceae tree that is endemic to the region of dry forests of coastal Ecuador and northwestern Peru, have been found in burials of Las Vegas people. It is of interest to understand that the barbasco fruits are used for washing hair against dandruff, for cleaning clothes, also as a potent ichthyotoxic used for fishing, and also for disinfecting wounds in cattle. The several uses preserved to the present by tradition of people from coastal Ecuador and connected to the evidence of fossil fruits found in the burials of Las Vegas people is the evidence that they knew about the uses of plants. That is before even the Egyptian Empire period. It is also of interest to talk about the applications of native species in the region. I would like to talk about a floating island project that was developed by the Ministerio del Ambiente and a local environmental company that is PSI. Concerned about a big problem that has the city of Guayaquil, that is the shed of human and even industrial waste into the mangroves and the Gulf of Guayaquil. A number of islands, artificial islands, were settled in the Palanqueado Creek, the matrix were elaborated from recycled material, and the purpose was that the species of plants were absorbing the excess of nitrogen, extracting the nitrogen from the polluted waters, and also contribute to capture heavy metals as lead and cadmium. The plants of Rhizophyra grew up as fast as 1 meter per year, or sometimes even a bit more, being of faster growing than the natural populations in mangroves. After a couple of years in the area were observed larger sizes of crabs, aquatic crabs of genus Calinectes, as that at the upper left corner. And also larger sizes of fish were observed among the island. Yeah, it called attention, and people were there for fishing even. That means kind of recovering not only the quality of water, but also the uses of the area. An oxygenation system was also implemented there, and the results were really amazing. Conclusions. It is needed to develop more effective programs of conservation and restoration of ecosystems, including the rescue of endangered species of plants. We need to accelerate the process of botanical collections and studies before ecosystems get seriously affected or even destroyed. Further, phytochemical studies are urgently needed. Thank you very much for your attention. Feng Shan Kanxiani. Muchas gracias a todos.
Muchísimas gracias. Thank you very much, Javier. We would like to ask Andrea to help us with the questions and answers, and if you please.
Yes.
I hope Javier is able to answer or to join. Otherwise, what we would do is we are sending him the questions via WhatsApp, and then he will be answering in the same way. So please, if you, Javier, are you able to connect? Are you here or no? Yeah.
No.
Okay, so yeah, Andrea, if you please could read the
Yes.
questions. Yeah, thank you.
So the question is if there are any species of Carenia and Lecitidaceae in Ecuador, and if they are studying those species in Brazil. I sent the question to Javier, and he asked me to give you his email address so you can directly write him about the question. But about the other part, that if how can you contact Scott Mori, he just said that he passed away, so it's not possible to contact him.
Okay, so do we have more questions or?
No, there was just one question. And I already sent the email to Maria Cristina. Please, if you can contact Javier through his email.
Yeah, if you have Javier's email, if you please could type it in the chat so people could copy. Yeah. Oh, good.
Yeah,
good.
Already.
Yeah. Yeah. So Lily had the question. You had the hand raised. So if you please could type the question in the chat or in the questions and answers.
No, she just lowered her hand. I don't know if she already had. Okay. We have another question for Javier, but he's not with us today. So If you could just email him, please, the question so he could be happy to give you an answer, please.
So Javier tells me that he is able to listen to the talk and to participate. It's only that he's not able to connect to the talk. So I have asked Javier if he could answer Katya's question. Otherwise, yeah, we have Javier's email in case. So you could send him the question by email. Yeah. Okay. So Javier is typing. So yes, unfortunately, Scott Mara, one of the experts on Lecythidaceae, along with Javier, and unfortunately, Dr. Mori passed away a few months ago. This, with the pandemic, it's been difficult because several colleagues, botanists, are not with us anymore because, yeah, problems. Yeah. So Javier says that please write to his email questions and comments as he has to leave right now from this meeting because he has giving another talk in another in another event organized by his university. So I would like to ask Xu Jun again, if you please could introduce our next speaker. I'm going to share the screen, W3.
Okay.
So I will share the screen so we could see, so Xu Jun could read the biography from our next speaker.
Yeah, please enlarge it to full screen.
Can you see it now?
Yeah. I'm very happy to introduce Dr. Yao Wuxing, a very, very excellent young botanist in China. He works now in Sichuan Tropical Botanical Garden, Chinese Academy of Sciences. He received his PhD from Kunming Institute of Botany in 2010 and worked at the University of Zurich and the Field Museum in Chicago as postdoc between 2010 and 2016. His main research interest is on the plant diversification and the biogeographic history of flowering plants in Northern Hemisphere, especially in Alpine plants. Recently, his group focused on the evolution of Hangduan Mountain and East Himalaya Alpine flora, and he published more than 60 peer-reviewed papers, including Science, PNAS, Systematic Biology, Evolution, Global Ecology, and Biogeography. This year, Dr. Yao was selected as Distinguished Scientist by the National Science Foundation of China. This is very, very difficult in China. So this represents Dr. Yao is one of the best and distinguished scientists in China. So let's welcome Dr. Yao's talks, please. Yao, could you?
Yes, sorry, I cannot turn on my camera. I don't know why. Alina, can you allow me to turn on my camera?
Yes.
And also share my screen.
So I just gave you the rights as a co-host. So please, could you check if you can share the screen?
Yes, now it works.
Okay.
Okay. Can you see my slides?
Yes.
Yes, but then could you make it in a presentation style? Because right now it's showing 2 slides at once.
Okay. Is it okay now?
No, full screen. Use the full screen.
It's a bit strange. Don't know why.
Now is good.
Good.
If you have 2 screens, close one. So the full screen will be shown.
Is it okay now?
No, there are 2 screens, one bigger one, another small.
I don't know why. It's quite strange. Try again. Try again. Still, right?
We
It's
don't see
okay.
anything right now. Before we were able to see.
Can you see the screen now?
Yes,
Is it okay
Okay.
now?
Yeah.
it's okay.
Okay. Seems quite strange to me. Okay. Hello, everyone. My name is Yao Wuxing. I'm from Xishuangbanna Tropical Botanical Garden. And so firstly, I would like to thank Alina and Professor Ge for inviting me to attend this symposium. Today, I'm going to talk about like the origin and assembly of the world's richest temperate Alpine flora. The first slide I would like to show, just want to show you where is ICTBG. Actually, ICTBG is located at the southwestern border of China, and it's very close to Laos. It's at a very remote area, and it will take 36 hours flights from ICTBG to Quito. So, as we all know that like mountains have fascinated biologists since several centuries ago. The father of the biogeography, Alexander Humboldt, are the first one to make a cross-continental comparison of different vegetation types. And I had defined the distribution roles of vegetation in relation to conditions such as altitude and temperature. Humboldt's vision was that everything in nature was interconnected, implying a connection between the biotic and abiotic realms. Why mountains are so fascinating? Because they have more than half of the terrestrial biodiversity. Among them, the tropical Andes and the temperate Honda Mountains stand out for their high biodiversity and complex geological history. In a recent review paper, the authors noted that the high biodiversity of certain mountains reflects the interplay of multiple evolutionary mechanisms, enhanced speciation rates with distinct opportunities for coexistence and persistence of lineages, shaped by long-term climatic change, orogenetic histories, and landscape evolution. Therefore, mountain biodiversity bears the signature of deep time evolutionary and ecological processes. Recently, the term geobiodiversity has gained increased interest in the union of biological and geological sciences. In addition to contemporary conditions, deep-time historical processes such as geological events, such as mountain building or long-term climatic fluctuations, interacting with landscapes evolution that potentially affect the rates of insect speciation or extinction of lineages, and thereafter affect regional biodiversity. As we already know that there's an elevational gradients in mountain ranges from lowland forests to treeless Alpine region. Compared to the low elevation, the Alpine region is among of the high geodiversity and more sensitive to environmental change, and so affected strongly by geographical fragmentation and the speed of uplift and the climate change. Therefore, the evolution of the Alpine biome was entirely dependent on orogeny, as the ecosystem could only have developed once the mountains had reached a sufficient height. The emergence of Alpine biome linked to the orogeny indicate that a full altitudinal road nation was formed. As you can see, the Alpine biome can be found at high elevations in the mountains above tree line around the world, which represent the highest terrestrial ecosystem in the planet. Whereas Tundra is restricted to the Arctic region, they both characterized with low temperature and short growing season. Considering the harsh conditions that settled, they usually start to be very low biodiversity compared with lowland or low latitude. There are about 8,000 to 10,000 species Alpine plants around the world. However, on the mountains in the temperate region, which is located at the southeastern Tibetan Plateau, harbors exceptional Alpine diversity that we know in the northern hemisphere, which comparable with the tropical Paramores. The Paramores mainly distributed in the northern Andes of South America and adjacent southern Central America. It is mainly dominated by giant roseate plants. A few years ago, we went to Ecuador for a biography meeting, and we visited the Paramores. It was very impressive. But we're also very curious about why there's so many Alpine plants, since there's full of this kind of giant roseate plants and grasses. The Alpine plants are usually thought to be very young and rich in adaptive radiation in mountain regions. The Paramore is likely the product of unique adaptation to an extreme environment that evolved during the last 3 to 5 million years. When the Andes reached an altitude that was capable of sustaining this type of vegetation. Another example is the rapid radiation of the genus Lupinus. It's only originated in the last 3 million years. Some other examples like Actinitum and Delphinum, they're also very young. When we look back to the Honda Mountains, there about over 3,000 species of seed plants belonging to over 300 genera, which represents the richest urban flora in a temperate region. Actually, it's comparable to the Paramores. Paramores harbors about 3,400 species, but it includes mosses, lichen, etc. So the Honda Mountains, 3,030 species are all seed plants. If we include Himalayas and Tibetan Plateau, it arguably represents the richest alpine flora in the world. The dominant plants in the Honda Mountains are genera like Saxifraga, Cordilleras, Salsuria, Pedicularis, Salix, Rhododendron, and so on. There are also rich endemism plants and highly specialized morphological plants such as the snowball plants and greenhouse plants and cushion plants. So when you compare the alpine diversity of the Honda Mountains with other regions, we find that the Honda Mountains have a very high alpine diversity and even close to the top Paramores. So we're very curious, why do the Honda Mountains have such high alpine diversity? When and how was the alpine biome assembled? And what role did the Honda Mountains play in the biotic interchange among the Tibetan Plateau and the adjacent regions? To answer above questions, we need to know the temper, when, how fast, and the mode through what processes by which the alpine biome in the Honda Mountains was assembled through time. We also wish to know how and why this vary in time and space. So our research goal is to trace back the origin of the alpine biome and to acknowledge through what processes the alpine plants were assembled and what's the drivers behind them. With about questions in mind, we're wondering the rules of mountain building and climate change in development of alpine diversity in the Honda Mountains. Honda Mountains is located and adjoining with the Qinghai Tibetan Plateau and the Himalayas. The geological history among them are distinct. Regarding to the climate, contrary to the acidification in the interior of Tibetan Plateau, Honda Mountains and the Himalaya have experienced an intensification of ancient monsoon since the Miocene, which brings plenty of rainfall in summer. When we look back into the uplift history of Tibetan Plateau, we find that there might be already very high mountains in South Tibet and part of the Honda Mountains prior to Neogene based on paleontological and latest geological evidence. Later on, there's an extensive uplift across the Tibet, including the central Tibet, the Himalaya in the south, and the Honda Mountains in the southeast. Most part of the plateau were formed since the early Miocene, and the mountain ranges surrounding the Tibetan Plateau, such as the Himalaya in the south, the Paramore in the west, and the Honda Mountains in the southeast, also extensive developed since then. During this period, a remarkable biotic turnover also occurred. According to the latest fossils found in Central Tibet, a tropical or subtropical paleoenvironment environment in the latest Oligocene was replaced by temperate elements by the early Miocene. So we are wondering if this period also key time for the development of Alpine balm. According to the geological and paleoclimate background, we assume that there are at least two requirements for the establishment of Alpine balm, that is high elevation and cool climate. Considering the vertical vegetation in mountains, the assembling of the Alpine balm will include in situ speciation, local recruitment, and colonization from other regions. And we test that if dynamic speciation and colonization rates through time are linked with the dynamic mountain building. Specifically, we propose there might be 3 stages for the development of the Alpine plants in the Henan Mountains. The first stage is the initial emergence of the Alpine plants before the Henan Mountains intensely uplift, but with Alpine habitats only restricted to limited high enough areas. The second stage is the rapid development of Alpine plants in the Henan Mountains, with increased in situ speciation and colonization because the extensive mountain building and new cooling. The last stage is the expansion of the Alpine plants to adjacent region from the Henan Mountains, since the niche in the Henan Mountains has been gradually occupied. To conduct the biogeographic analysis, we selected 18 clades, which represent some of the most diverse families in the Alpine balm of Henan Mountains, as well as the close known relatives in lower elevations and other biogeographic regions. Also, they should have sufficient molecular data available to infer the phylogenies. As we focus on the assembly of Alpine plants in the Henan Mountains and the relationship with its adjacent regions, we delimited 4 biogeographic ranges specifically, and 2 biome types. And we selected related fossils for calibrations and conduct the analysis in BIS2. We analyzed time-calibrated phylogeny of 18 groups of flowering plants by using a joint model of biome occupation, geographic range evolution, and lineage diversification that allowed us to infer how Alpine biotas of the Henan Mountains, Himalayas, and K2P were assembled through time. To integrate range and bioevolution, we apply a new biogeographic model in which geographic range and biome occupancy jointly evolve with species birth and death. Our model has 4 free rate parameters, which including local extinction rates, speciation rate, dispersal rate, and biome transition rate. We also constrain the endogenetic metrics that dispersal events and bio shifts could not occur simultaneously, and that biome shifts occur in all areas of a species range. Our performance of biogeography model was implemented in web-based software based on the classic model. And then we perform stochastic character mapping to estimate the dynamics, range, and biome shifts, and lineage diversification through time. Stochastic mapping will sample the time and number of transitions along the branches of a phylogeny. At last, we calculate the speciation rate and colonization rate across time. The speciation rate is calculated as the number of in situ speciation events in 1 million year periods divided by the cumulative sum of in-situ speciation and by shift and colonization minus local extinction events. The same for the colonization rate. So here are some of the results. Our first finding is that we found contrasting evolutionary histories of alpine and non-alpine biome in Henan Mountains, Himalaya, and Tibetan Plateau. The red line represents the process of in situ speciation. The brown line represents biome transition, and the green line represents the colonization. So as you can see, we found that the alpine lineages are younger than non-alpine lineage throughout all regions. And assembly of alpine biome in the Henan Mountains and Himalayas is dominated by in situ speciation, whereas the assembly of alpine biome in Tibetan Plateau is dominated by colonization through time. Notably, in the Himalayas, the cumulative number of in situ speciation overtakes that of colonization at around 50 million years ago. Regarding to the assembly of non-alpine biome in the Henan Mountains, it was dominated by the in situ speciation as well, whereas in the Himalayas and Tibetan Plateau, the assembly of non-alpine biome was dominated by the colonization events. So therefore, we found that the alpine flora of the THH region is surprisingly old, which most likely represents the oldest alpine flora in the world. This figure shows the alpine plant diversification through time in relation to the dynamic tectonics and climate change in the THH region. As you can see, the speciation rate increased firstly in the Henan Mountains and increased dramatically following the Oligocene and Miocene transition and reached their peaks at around 15 million years ago. This is also the periods of the active tectonic events happened in the Henan Mountains. Continuing high rates of in situ alpine diversification since the mid-Miocene climatic optimum and temporarily congruent with intensification of the Asian summer monsoon. The monsoon in summer not only provides more water for plants to grow, but also can create more rugged topography by erosion, resulting in deeper valleys and more incised mountain ranges. Therefore, provides more opportunities for new species to evolve and diversify. In the Himalayas, the in situ speciation accelerates since the early Miocene to the mid-Miocene. Is coincided with the Himalaya orogeny, which uplift to near present elevation by the mid-Miocene. By 50 million years ago, the Himalayas has already reached to its present elevations. Subsequent peaks at 30 million years and 10 to 5 million years occurred during periods of continued orogeny and summer monsoon intensification. In the QTP, by contrast, the dominance of colonization in alpine biotic assembly relative to in situ speciation since 80 million years ago reflects orogenetic and climate differences from the Hunan Mountains and the Himalayas. From this figure, we can also find that the colonization rates dramatic increase since the Quaternary, and the main source of is the Hunan Mountains, implying that Hunan Mountains is a major refuge and source of the Alpine plant. The QTP has experienced a strong orographic Himalaya-induced rain shadow since the mid-Miocene. This may result in pronounced environmental change and reshape the biota of the QTP, with extinction of previous residents and colonization by cold-adapted species from neighboring regions. Our results also indicate that the Hunan Mountains are the primary source of the Alpine diversity in the Tibetan Himalaya Hunan Mountain region. This figure shows the biotic interchange among different ranges. As you can see, the majority number of Alpine plants in Himalaya and QTP are from the Hunan Mountains. On the other hand, the Alpine lineages in the Hunan Mountains were largely assembled by biome shift from lower elevation. 44% and 42% of Alpine plants colonized Qinghai Tibetan Plateau and Himalaya are from the Hunan Mountains. So this is the main result we found in the previous study. Now we are expanding our study scope to the whole Northern Hemisphere. Our aim is to quantify the biotic interchanges among different mountain ranges in the Northern Hemisphere, probably in the future to a global scale, and to determine the effects of historic factors like mountain uplift and climate change on the regional plant diversification. Because of comparable climate conditions, the appearance of similar species are general in both the Arctic, the high mountains of Eurasia and North America, suggests there might be frequent exchanges between Arctic and Alpine plant assemblages. The first question we are going to ask is, where is the primary source and where is the sink of the present Alpine plant diversity in the Northern Hemisphere? Based on previous study, we hypothesize that the region, which have many old lineages, might be the primary source, and the wide area of Arctic region may be the sink of high colonization events. And thirdly, what is the relative role of climatic changes and tectonic events play on regional plant diversification? Actually, we did get some primary results. As you can see in the figure, different regions, mountain regions, have very distinct evolutionary histories. The THH region still represents the oldest history, but for the European Alps, it peaks after 5 million years, the same as the Rockies. But this is just the primary results. We expand our sampling and we include more clays to give more detailed results. This is what I taught for today. For this, I would like to thank my PhD student, Dingwen Na, who did most of the job. And I would like to thank Rick Ray and Bob Spicer, our collaborators on this project. At last, I would like to thank you for your attention. Thanks. I'm happy
Thank
to
you, Yao.
answer your questions.
Yeah, thanks, Yao. Is there any question?
Yes, I have a question.
Hi,
Yeah. So, sorry. Here in Ecuador, the highest diversity of plants it's more like in the cloud forest, which is between 2,500 up to the 3,500. How is the diversity? Do you have like a cloud forest in the Andean mountains, and how is the diversity for that, for the lower altitude range of the Alpine Institute?
Yes, actually, it's the same in the Honda Mountains. The highest mountain is in the middle, the kind of a cloud forest. Actually, also like the meadows, the middle elevational meadows, they have us the highest biodiversity. They're quite similar to the Andes, actually.
Nice.
Mm-hmm.
Thank you. Okay, so we have one more question. So Andrea, if you please could help us with the questions and answers.
We have two questions. Why mountains harbor so many species, higher niche diversity?
Yeah, that's a good question and a very big question. Actually, this main question we are going to answer probably yes, for sure. The high niche diversity is the main driver, but what created the high niche diversity? I think it's a product of long geological processes and the interplay between geological and biological processes. They both contributed to the high species diversity. So the second question is...
why is the global analysis focused on the northern hemisphere? What about the southern?
Yeah, so I mean, I think the main reason is actually we don't have we don't have enough data for the southern hemisphere. I'm not quite sure, but some very large clays we searched for the gene bank, then not enough, but also it's quite complicated, especially for some large families like Asteraceae. They do have very distinct histories. So actually we are going to do the global analysis, including the southern hemisphere. But currently it's a big task and quite difficult. Mm-hmm.
Thank you. We have two more questions. Is the biogeographical model you developed in your science paper open to the public?
Yes, you can find it from the supplementary information. It's public, it's open.
Thank you. Do you agree that mountains are both cradles and museums of a species in your analysis?
For sure, yes, I do agree with this. So because, especially like Andes and the Honda Mountain, Himalaya, they are cradles for, new species formed, but also they are museum for some old species and refuge for many species, especially in the Ice Age.
Thank you. So we have some more. Is there any relationship between the Northern Hemisphere Alpine flora and the Arctic flora?
Which one?
Is there any relationship between the Northern Hemisphere Alpine flora and the Arctic flora?
Yes, definitely. And someone have compared the Alpine flora, from the QTP and the Arctic flora. For example, like Arikisi, I think many clades occurred both in the Alpine flora and the Arctic floras. As also I showed in our primary results, there's some connection between the Alpine flora and the Arctic flora.
Okay, thank you. The mountains face climatic variations and many times very adverse conditions. Then, why it harbor high diversity?
Sorry, I don't quite understand I think I answered this question before, right? You can send it to the previous one.
Yes, the high niche diversity. Yeah. And the last one, between the sound studies in China and Ecuador, is there any data on the similarity of the species?
I don't think so. As far as I know, I don't know about this, but at the species level, I don't think so. But they do some clades like leguminous, Asteraceae, Gentianaceae, they both diversified in the Ecuador and China, but species level, I don't think so. But even genetic level, I don't think there are many shared general, but in family level, they share many families.
Thank you very much. Thank you very much. We don't have more questions.
Thanks.
Thank you. Thank you for your presentation. It's interesting.
Thanks a lot. Thanks, Alina. So now I have to. Okay, how do I?
I have stopped sharing.
You can stop.
Yeah, so it's okay now. So I would like to introduce. Thank you. So I would like to introduce to our next speaker. Sorry. Okay, so it's my pleasure to introduce a friend of more than 30 years, Katya Romoliru. She is a professor of the Faculty of Natural Sciences at Catholic University in Ecuador. Her research interests focus on the diversity of high Andean plants. She has made original contributions to the study of high Andean flora of Ecuador, especially on the systematics of the family Rosaceae. She has published 45 papers in international journals as the first or corresponding author, co-first and co-author. She was the first Ecuadorian to publish the treatment of a plant family in the international journal Flora of Ecuador. She has trained and mentored students who have continued her line of research. She's been successfully funded by the Alexander von Humboldt Foundation in Germany and the National Geographic. Something very important in Ecuadorian science is a well-known award. So in August of 2020, Dr. Romoliru was awarded by the National Award Eugenio Espejo in Sciences. Her talk will be about the endemic flora of the Ecuadorian Paramore. We will also share her recording, And please feel free to write down your questions. Katya is in the room, so she will be answering directly or through Andrea. So let me share the presentation. And please let me know if you can hear it.
Good morning to all of you. Thank you very much to the...
Were you able to hear, please?
Yes, Alina.
Thank you.
Please make it, okay, there, thank you.
Good morning to all of you. Thank you very much to the organizer, especially to Alina Freire for the invitation to this international symposium. I am very pleased to share this space with colleagues from Ecuador and China. I'm going to talk about the endemic flora of Ecuadorian Paramos. And my talk is going to be about the endemic flora of Ecuadorian Paramos, as I mentioned, and it's structured in 3 parts. The first will be about a brief introduction of the importance of Paramos as centers of the biodiversity and endemisms in neotropical mountains. The mountain system of which the Paramore are part contains more than we can see. In this graphic, for example, on a schematic cross-section of an imaginary tropical mountain that I took from one publication, a recent publication by Perigo, Horn, and Antonelli, gives us to understand that apart from the diversity that we can see along the mountains, in A, for example, here, we also have the visible biological and geological aspects that are here in B, but also the hidden geological climate process and diversity, such as sedimentation, which is in C here, soil, and orogeny. All these aspects interact, and this interaction between climate and mountains produce a very complex environmental heterogeneity that leads to a great diversity of species. That is the one that we have here. In mountains, gene flow, reproductive isolation, and events such as hybridization and polyploidation play an important role that can lead to speciation. Isolation is important for speciation and is consistent with the increase in the percentage of endemism, with elevation found in high islands and continental mountains. About endemism and Paramore, although speciation and endemism are not automatically linked, trends in endemism should generally reflect gradients of speciation. The flora of the Andean Paramore is the most species-rich of tropical alpine regions, and most of the plant species found in Paramore are endemic. Regarding to the origin of the genera in the Paramos, approximately 45% of the genera are of temperate origin. Another 45% are of tropical origin, and 7% are endemic. This is regarding to genera, not to species. The Paramore is the youngest biodiversity hotspots in the tropical alpine part and richest tropical alpine province on Earth. It includes 15 phytogeographical units and around 5,000 plant species, and circa 60% of these 5,000 plant species are endemics. So you can see here the map, and the Paramore goes from North Peru, Ecuador, Colombia, and Venezuela, and also part of Costa Rica, and a very high part of Costa Rica is also considered a Paramore, according with those publications. The high biodiversity of Paramores is related to the diversity of ecological conditions linked to glacial geomorphology, creating an ideal setting for rapid allopatric speciation. So I think I would like to maintain these two words, allopatric speciation, because all of these factors that I mentioned before setting for a rapid allopatric speciation, which is probably the main reason for the diversity in the Paramores. This allopatric speciation that would allow a faster occupation of the newly available and novel niche space for faster and more recent explosive diversification. The high elevation ecosystem in the northern Andes belong to the Paramore biogeographical province. So this is a biogeographical province, okay? But the tropical biodiversity hotspots is threatened by is critically threatened by climate change. So the climate change affects directly to this region. Altitudinally and traditionally, the Paramore has been divided in three main elevation belts. First one, the sub-Paramore from 3,000 to 3,500 meters, or lower free or shrub dominated by ecotone with Andean forests. Second one, this one, mid-Paramore from 3,000 to 3,500 to 4,200 meters, or Paramore proper, including vast grants and giant rosette community. And the third one, super Paramore, above 4,200 meters with gradually scattering vegetation. I have to mention that here that this is not exact. For example, in Ecuador, we have that in the northern part, the Paramore could start at 3,000, even 3,500 meters, while in the southern part, especially in Loja, the Paramore could start lower at 2,800 meters or 3,000. You have already a good Paramore. So it changed. No, the altitudes are not exact in every region. And also I have to say that actually 11 different types of systems have been proposed of the Ecuadorian Paramores. I took that from my publication from the Ministerio of Agriculture in Ecuador and of Environmental of Ecuador from 2012. The Paramore is not only important because it has a lot of endemic species, but because it provides environmental and socioeconomical services. For example, protection of water sources, erosion control, and microclimate regulation, and they are a habit for numerous native and endemic species. It contains large areas of watersheds and springs of rivers and streams, which supplies water to people living in lower altitudes. For example, most of the water that came to Quito in Ecuador, it came from Paramores. Soils have the ability to behave like a sponge or cushions that capture rainforest from the mountains and gradually releases it downstream. As the second part of my talk, I will speak about endemics of the flora in the Ecuadorian Paramore biodiversity and example of vascular plants. Here we have a current potential distribution of Ecuador. I would like to emphasize that it's a potential map. So in dark gray is the mid Paramore from 3,000 to 4,200 meters, mid and lower Paramore, let's say. And in red is the super Paramore. Here in red, the super Paramore. And but about the mid Paramore, not all this gray is Paramore now. So that is why it's a potential, because great part of this now is used for agriculture, for example. And here we can see the characteristic super Paramore vegetation from nanos, sublands, cushion vegetation, desert with shrubs, and periglaciar desert. About the numbers and endemic flora of the Ecuadorian Paramores, there are about 660 species of vascular plants. Approximately 50% of all are endemic flora of the country, in an extension of 7% of the national territory. So I want to say that the Paramore occupies only 5 or 7% of the national territory, but it has 15% of all endemic species, endemic flora of the country. The families with the highest number of species are Asteraceae, Orchidaceae, Gentianaceae, and Poaceae. Here we can see Erythrophium yanganatense from Cerro El Monzo. This is in Yanganates, a very remote place in the central Andean Paramore, Ecuador. And about the families, here we have the 15 families with more number of endemic species, and the percentage is also here. And we can see this species is Phlodocaldaceae azorelioides from Asteraceae, grows also in Yanganates, in this very remote place, as I mentioned. Azorelioides because has the leaves are Azorella, another genus from another family. And this is Calamodrostris aurea from the Poaceae family. This is from Antisana, which is in the northern east north part of the Andes. Another finding, Asteraceae family. Here we have this rediscovery of Xenophilon acerosum, also from Asteraceae. It was known also from the type collected 73 years ago, but recently a botanist, a colleague, Peter Sklenar, this is from Czech Republic, but he has been working in Paramores of Ecuador during years, and he collected this in another place in Azuay, in Cordillera, Cordoncillo, and the type was from Loja. And here we have another species from Asteraceae also, but it is Verneria spatulata, is another genus, and it is growing in Antisanilla and in the cushions of Distichia. It is a new record. It was only known from Bolivia, but now it has been found in Ecuador. So we published this in 2020 with Peter Sklenar. And here are the genera with the highest number of endemic species we have here. So it changed a little bit because the genus with the highest number of endemic species in the Paramore is Gentianella from Gentianaceae. Here we have Gentianella foliosa, and then we have Drava. It's another genus, but this is from the family Brassicaceae family. Here we have Drava longiciliata. It is also from Yanganates. Okay, and now the distribution of the Paramore endemics by altitude range. We have most of the species are found in this altitude, of the endemic species are found in this altitude in Ecuador, in Paramore. So we have more than 230 number of species endemic, and more than 80%, excuse me. This is Monticalia speciosa, a species that we found and we published it with Joey Calvo. It is an Spanish botanist, and it is from Papayacta, Napo Papayacta. It grows close to Lepis forest, and this lagoon is Anteojos lagoon. The degree of threat of the endemic flora in the Paramos is alarming. Really, here the number of plant species of Ecuadorian Paramo on each of the IUCN threat categories. You can see that critical danger is 20, probably now is more, but is almost 10%, and in danger is almost 30%, and vulnerable is 40%. So it's very alarming. These are very alarming, those numbers, and especially that 75% of the endemic species are threatened, and only 48 of these are inside the national system protected areas, that means that only 40% of 48% is protected. About the degree of threat of the endemic flora of the Paramos, I took this from the Peer 2020 publication, and they said, Peer et al., they said 15% of our marrow species showed a significant national extinction risk by the year 2100. From this, 25 of all super Paramo species, 25% of all are super Paramo species, supporting hypothesis that super Paramo species are generally more in risk than mid Paramo ones. Many super Paramo that are endemics species are posed as threatened. For example, Cerastium candicans that we have here. This is a Caryophyllaceae from Ecuador also, and we have Draba de Presa is here, Draba de Presa from Brassicaceae. But we have also national Paramo endemicas, Barcia pumila, Loricaria antechanensis, Viola polycephala, for example. Here we have Loricaria antechanensis from the Asterisea, and this I took also from BioWeb. This photo is from BioWeb, this database from the Herbarium QCA. And Pierre et al. In 2020 says also that studies alert to the maximum extinction risk of 9%, some of which were already classified following by the IUCN system and threatened. As a conclusion of this part of the work, I have to say that Paramo ecosystems are home to a large number of endemic species that are the result of extraordinary events of radiation, diversification, and geographic isolations, and also that high elevation endemic species may be negatively affected by climate change. I should say that not maybe, they are already affected by climate change. Even so, if elevation drives speciation, future speciation can be maximized by conserving mountain barriers, especially at lower latitudes like equatorial line, like for example Ecuador. Significant losses in species distribution and change in communities, richness and composition suggest drastic species impact and call for further. So we need more studies and more research considering additional factors such as land use. As the last part of my talk, I'm going to tell you about a case of study, the genus Lachemilla from the family. Lachemilla is among the 10 most diverse genera in Paramos from 3,500 to 4,500 meters. Here, two endemic species of Lachemilla from Ecuador, Lachemilla yanganatensis from the Yanganates, the place from the central Andes of Ecuador, this remote place that I talked about before. And here, Lachemilla angustata, it's endemic species from the province of Azuay and Loja also. The same Lachemilla angustata, this is the type collection that is in Aarhus, the University of Denmark, and the herbarium of Aarhus, and there is another type collection also in the herbarium QCA. Why Lachemilla? not only because, as I mentioned, Lacemilla is one of the most diverse genus in the Paramore, but it is well represented also in the Neotropical mountains from 2,000 meters. It has more than 20 species names that we have to solve it, because there are a lot of names that were published, like Alchemilla and other like Lacemilla. So the nomenclatural work is very high, and somebody has to do it. And also it occupies different types of habitats: Paramore, forests, punas. It's because also it's important because it's morphologically diverse. We are going to see that, and because it forms cushions that act as water reservoirs in Paramore, and also some of them are medicinal. Those are the publications that we have write with my colleagues and with the students of my. As I mentioned, Lacemilla is morphologically variable. Here we have herbs, shrubs, but more herbs. But the difference are in the habitat, and also on the leaves that we can see in the next slide. Those are the groups that are proposed, the group infrageneric classifications. The first revision of Lacemilla was done by Perry in 1926, and she considered Lacemilla like a section of the genus Alchemilla, and she proposed 60 series and 41 species, and those are the series. Later, Rothmaler in 1935 and 1937, he proposed as a genus Lacemilla, not like a series, not like a subgenus, and he considered 6 subsections and 71 species. Here, for example, one of the section, Aphanoides, with these parted leaves, 3 pentapartite leaves, Orbiculata with these orbiculate leaves, Nivalis with these verticillate, very modified leaves and stipules, pinnate leaves, for example, and Diplophila. This is a very specialized species, because it has these 2 leaves that came from the mid veins, so extra leaves. That is why the name Diplophila. The flowers are also different, but not so different as the leaf. About distribution, Lacemilla is distributed from Mexico to North Chile and Argentina. Most of the diversity of Lacemilla is in the northern part of the South America Andes. Here we have approximately 40 species, and 18 to 20 species in the northern, and 20 species at the southern part. So most of the 60% of the species are in this region. So we consider that why are more species here? Probably it is this coincide with the from rapid ecological tradition related to the most recent Andean origin about 2 million or 3 million years ago. The taxonomy of Lacemilla in Ecuador at the beginning, before 1996, 12 or 10 species were recorded for Ecuador. When I did the treatment for rosacea for Flora of Ecuador, I consider I record 24 species of Lacemilla for Ecuador, and then we have published it with Diego 2 more new species for Ecuador. So we have 26 species of Lacemilla in Ecuador. I wanted to do the treatment, the revision of the genus for the Neotropical region. So I went to Germany and did my postdoc and start this work. And we did with some of my colleagues in München in Germany, and we started one study about the first study about the phylogenetic phylogeny of Lacimilla. So as a result of this study, we found that Lacimilla is a monophyletic genus, and also we found moderate compatibility with previous morphological infrageneric classification. But an interesting find was that there are incongruences between nuclear and chloroplastic phylogenies, and possible causes of these incongruences we mentioned on this publication that could be polyploidy, hybridization, and reticulate evolution. When I came back from Germany to Ecuador, I had a student, Diego Morales, and he started the phylogeny of Lacimilla with all the species in Ecuador, and later he went to do his PhD in United States, and he had the opportunity to visit from Mexico to Bolivia and collecting most of the species of Lacimilla. And as a result, he did his PhD, but also some publications about Lacimilla. And this publication that we did together, we proposed a new classification of Lacimilla species. So this was the classification of Perry, this is Rothmeiler, and this is the classification that we proposed in this study. So we have the clade pinnate clade, verticillate, orbiculate, and tripartite. And this, the most important is that we found 4 clades and 1 clade of hybrid origin. For example, this series orbiculata is here in Perry, and here is in subseries radicantes in Rothmeiler, and here is in orbiculate clade with only 2 species. Most of the other species are from hybrids origin. Here we can see the clear pattern of incongruences between nuclear and plastidic phylogenies, evidencing a complex and reticulate history. For example, this is a tree using chloroplastic DNA TRNLF markers, and this is from the nuclear ITS. The species, for example, Jaramilloy, is in the same clade in the chloroplastic and nuclear, but is in different position. And other example is Lacimilla rupestris. Here is in the verticillate clade in the chloroplastic tree, and here is in the orbiculate clade in the nuclear tree. So clear pattern of incongruences between nuclear and plastidic phylogeny, evidencing a complex reticulate history of Lacimilla. This hybridization process were found to be the most likely explanation for these incongruences. And this is the concatenate tree excluding possible hybrids. So here we excluded the possible hybrids. They are only the, let's say, the pure species. Yeah. So here we have this clade tripartite with this leaf form, and clade verticillate, clade pinnate, and clade orbiculate. So this consensus concatenate tree excluding possible hybrids, and 4 evident clade which correspond roughly to earlier classification. And here we have the reticulate evolution. This table is the phylogenic network analysis, and it includes the hybrids which the taxa that possibly originate them. The red species of hybrid origin, the red species represent species of hybrid origin from 2 or more clades. The colored lines, for example, these colored lines, connect possible parental species from of the taxa of hybrid origin. For example, this Lacemilla rupestris again could be a species of hybrid origin, and the colorate lines coming from here indicate the clades of the parents that could have hybridized to give origin to this taxon. It must have crossed a taxon from the verticillate. For example, verticillate is the green one, yeah, and with the clade pinnate is this orange, and even this orbiculate with this orbiculate with this yellow color. So these species could be from a hybrid origin from these different clades, from species from these different clades. So this is the example of reticulate evolution that has been found not only in Lacemilla, but in other genera of Rosaceae and other plants also. As conclusion of this work of Lacemilla, we can say that patterns of incongruences between plastidic and nuclear phylogenies are mainly the result of widespread hybridization and polyploidy. I have to mention here that we did polyploidy studies, and we find a high number of species in different species of Lacemilla in Ecuador, at least. Also, we can say that network analysis revealed a number of putative species of hybrid origin, evidencing a reticulate evolution that we have seen before. First attempt of classify Lacemilla species in a phylogenetic context yields a total of 61 species. I have to say that we have now 64 species because Diego published it 2 years ago, one new species for Mexico, and we published it 1 year ago, 3 new species for South America. And those species are separated into 4 well-supported lineages and slightly congruent with a previous classification. The origin of Lacemilla was estimated to be South America 14.5 million years ago, and then rapid accumulation of nested lineages during the last 5 million years ago. Further molecular and taxonomy studies are still needed to understand better this important genus of the Andean region, and especially of the Andeans, of the Paramores of Ecuador. I leave you with a reflection of Alexander von Humboldt, who was fascinated with the Andean region of South America, especially, and I special thanks to the people who helped me with this presentation, and thank you very much, all of you, for your attention.
Thank you very much, Katya. Very interesting, very interesting. So, Andrea, if you please would join us, and I will ask.
Yes. Thank you, Dr. Katya, for an excellent presentation, a nice talk. Very interesting indeed. We have some questions. I don't know if you will be able to open your microphone to reply.
Yes, I don't know.
Thank you.
Can you hear me?
Yes, thank you.
Okay, no, thank you very much.
So
okay,
I'm going to read some of the questions.
Yes, but I cannot read them. Okay, now I can do it. So
yeah, because we have some on the chat and some others in the answer and questions section. So how did you calculate the extinction rate?
Okay, we calculate the extinction rate for Lacemilla or the extinction rate for the plants of the Paramore? It is my question. For La Camilla, we used, well, non-extinction rate, but we used for the origin, we use the molecular clock. But for the extinction rate for the Paramores, I have to say that I took that information for the publication of Pierre in 2020, and they explain exactly how they calculate the extinction rate. And I have to say that they use several techniques to do it and to calculate and to estimate, you know, more than an exact amount. It's an estimation.
Thank you. So it is specified now that it's for endemic species.
It's for endemic species.
Yep.
Okay, it's for endemic species in Ecuador, or what?
Yes, I think so.
Yeah. Okay. So we calculate the extinction of the endemic species in Ecuador because I mean, it's like counting the species, and then we came to check the species which are not there anymore. This is in the field work, and so as I mentioned, there are more species that probably are extincted now, and therefore more studies are necessary to give an actual number of the species which are extincted. But now we are doing, we are preparing a new document for the Paramores, and Peter Sklenar and I, we are going to do the part of the flora of the Paramores and how is the situation, and therefore we are collecting several publications and also checking the list of species. And with our experience and with the publications that are already we are going to try to give a better and current information about it.
Thank you. So we have another one that it's if you have an updated checklist for the alpine plants in the Paramores.
Yeah, this was part of my former answer. We are working on that, but there is a publication by Perry and collaborators in Becht Paramore. I can give you the link, and it is a list of plants from Paramore, but from the whole region that I mentioned, from Venezuela to Ecuador and North Peru. And they mentioned that there are approximately 5,000 species, but not about the endemics. So that work is still waiting to update. But one of the lists that you can check is that one. I can give you and send the link. This is Bech Paramore by Perry. Is 20. I think it's 2014 or 2018. So it's a good list, but it still is not updated for the countries, and the endemic part is still need to do it.
Thank you. We have another question asking if is Paramore ecosystem widespread in Peru?
Yeah, in Peru, it's considered, they have more puna, which is a little bit different than the Paramore in the northern Andes of South America. Yes, they have more puna, but in the northern part there is still some regions that are considered as Paramore. But most of this place, the place like Paramore here is called more Puna in Peru, which has some differences in type of vegetation and type of geological structure. It is different, a little bit different. That is why they call more Puna.
Thank you. So I'm going to read now a couple of comments of some people. I hope I can translate them appropriate. So they congratulate you for the work on the South Paramores of Ecuador, and it states that there have been some studies in Yacuambí, Saraguro.
Mm-hmm.
And also we have another one that says that these studies have been done also with medicinal plants in UTPL. And on the same matter, they have realized that there is a higher endemism in the Paramores of the south of Ecuador. So is it more risk? The question is if there is more risk of extinction for herbs and shrubs in that region?
Okay, it's a very good question, but it's difficult to answer also, and especially from South Azuay and Loja, they have a different flora actually. Many genera have the limit, the geographic border is actually the southern part of Azuay and all the province of Loja. So actually you have more species. I'm talking also about other genera such as Rubus, which I studied from Rosacea, and there are a lot of species that are there. And I really think that the risk and the threat is in all Ecuador. The Paramores are really the conservation is very the situation of the conservation is alarmant because most of the Paramores are not in this, as I mentioned, in the protected areas, but especially I think in Loja could be more in danger, and there I called to check this and maybe to do to work for make a larger conserving area there, because actually you have many species that are endemic, and also that, as I mentioned, only go until this line, and you cannot find them in the northern part of Ecuador.
Thank you. We will have two more questions, and due to the time. So one is, how many species of polyploids in La Quemila?
In La Quemila, we have almost half of the species are polyploids. If you see the well, I cannot, but almost half of the species in La Quemila are from polyploid origin. So we have more or less 30 species or 55 species that we call pure species, and the other are from polyploid and hybrid origin, according with the study that we did it. Yes, and it is, as I mentioned, it did not happen only in La Quemila, but in other genera of Rosacea, and in other plants of at least angiosperma flowering plants in Ecuador and in the world also.
I think we have time for a last question. I think this one is very interesting. It's about molecular phylogeny. The 4 clades were resolved by both chloroplast and nuclear loci.
Yes. Yes, we use it chloroplastic TRLN and ITS and TAs from ribosomal nuclear genome. Yes, we use both.
Thank you very much, Dr. Katya. I think we don't have.
Thank you very much. I'm sorry because I don't know if it was too fast the presentation, but thank you very much.
I think it was perfect. Thank you very much for your presentation and the information given today. I would like to remind you, please, to register all the participants for their attendance for today. It will help us to follow on the certificates. And we will continue tomorrow. I don't know, Alina, if there is any other information to give to the people.
No, we really appreciate your patience, and again, I'm very sorry for all the situation we had at the beginning of the meetings. Thank you very much to the speakers, and thank you very much. And Xu Jun, would you like to say a few words? And then tomorrow we will resume, and I really hope things will work fine. So tomorrow we'll see you again at 07 a.m. Ecuador time, 22 hours China time. So from my side, thank you, Andrea, thank you, Fedia, and thank you, everybody. And please, Xu Jun, if you would like to say also some words.
Thank you, and Andrea. I hope tomorrow the Zoom system is good as now. Otherwise, many attendants cannot register, and it's a pity for both of us. Yeah. And also, please record the talk so that we can how to say that in English. We can having a look after the meeting. Okay. So, good night for Chinese people and good morning for Ecuadorian friends. See you tomorrow.
See you tomorrow. Thank you.
See you tomorrow.
See you tomorrow.
Bye-bye.
Thank you.
Thank
Goodbye.
you.